Hi, my name is Grégoire Hummel. I am the CEO of Phenospecs and I would like to welcome you to our company tour today. So idea what we have is to show you or give you a unique view behind the scene, to show you and introduce you to the people who are developing our products and to show you what we're doing here in Phenospecs, what is motivating us from day to day. So come and join me. So the best way actually to start the tour is actually here in the kitchen in our canteen, which we just renovated. So now we are actually in a greenhouse, which is constructed within an old Philips production facility. And this is the place where everybody is gathering, where we talk, where we discuss our results, where we have new ideas, where we have our monthly meetings. So it's really a very, very central point, an important point. This is also going to be the point where we're going to celebrate a big anniversary this year. So this year is going to be the 10th anniversary of Phenospecs. So yeah, 10 years ago we started with 2 of us. Today we are more than 30 people. We have a client base of 100 clients worldwide, and we have really a strong product portfolio with the plant eyes, with our gravimetric platforms, and we are really, really super proud with our development. So Phenospecs is a phenotyping company, and what is motivating us is really to develop tools which are designed for plant scientists, for biologists, for technicians, for people who are interested to generate data in order to create knowledge, but also to make them more efficient in creating new products for the agricultural market, to deliver new crop varieties. And so at the end, we are really at the service of agriculture, and we support the people to make agriculture more sustainable and more efficient in future. So this is really the thing which is driving us here at Phenospecs. So now we're going to start first, and I would like to introduce you to Max Peters. He's a service technician. He's a guy who is traveling around the world and installing our systems at our client sites, and also to make our clients happy. So he has a really important function. Come on, I'm going to show you and introduce you to him. So Max, when did you join the team?
I only joined recently, actually. I joined about 3 months ago.
And how's it going so far?
It's been really great. Yeah, I've been really enjoying it so far.
So what have you been doing and learning in the first 3 months?
So mainly about phenotyping, data-driven phenotyping, and our solutions for data-driven phenotyping.
Okay, so let's check in and see whether he learned his lessons. So explain us, what do we have here?
So right here we have the Phenospecs plant eye. So this is our 3D scanner, and this 3D scanner combines 3D data with multispectral information. It can scan in different light conditions, so it can scan outdoor, out in the field, or indoors in a lab or in a greenhouse. Then, whilst it's scanning, it will compute 14 plant parameters right on the go.
Okay, so what kind of parameters are we computing here?
So we can distinguish for these parameters in 2 groups. We have morphological parameters that say something about the shape of the plant. So for instance, the height or the leaf angle. Then we also have functional parameters that say something about the functionality of the plant. So for instance, there's Ndvi, which reflects to plant health, or different parameters that relate to, for instance, plant senescence or chlorophyll content.
Okay, so why do we have 2 plant eyes hanging here?
Yeah, so right here we have a dual scan setup. And that's actually a trick we do, a trick to overcome occlusion. So we can model the plants from 2 sides, and we make 2 models and then we merge them. This way we get a more complete image of each plant.
Okay, nice. So tell us, what do we have on the menu here? I see some basil plants, so what are you preparing here?
Yeah, so it's not pizza, but yeah, I'm doing a quick experiment here to quickly show how quick we can see an effect in these plants. So a part of these plants I will give a salt treatment, and another part I'll keep as control. And then we'll track how quick we can see a difference.
Okay, so when you are using this equipment, what are the typical steps and the routines you have to set up?
Yeah, so it's quite simple actually. There's only 4 major steps involved. First, we have to set up the experiment. That's what we do here. We place the plants and we have to create an experiment in the software. Then the scanners take over. So the scanners will scan the plants and create the 3D files. In the third step, these files will be processed. So we compute the parameters. Then the fun part starts for us.
Okay.
So we can start the data analysis and look at the data.
Okay, and what do you think? How quickly will these plants react to your treatment?
Yeah, that's something we really have to figure out right now. I'm not sure yet, but come back later and we'll have a look at the data.
Okay, good. We'll do that. Meanwhile, I would like to introduce you to Ronan Sharplightner. He's a client of us and working at the World Vegetable Center in Taiwan. He's operating a massive phenotyping platform. We call it FieldScan, where you can really scan hundreds and thousands of plants. So Roland, tell us, how did the FieldScan change your phenotyping activities at the World Vegetable Center?
Good morning. Thank you very much, Gregor, for having us. Well, how did the FieldScan machine change our phenotyping? I would say it made a revolution in our phenotyping. Before, we were limited to small populations, we were limited to hand phenotyping, and hand phenotyping is error-prone, is laborious, is lengthy. With the FieldScan, we can automatically scan at least 9 morphological parameters and several color and physiological parameters in an automatic manner. 7 days a week, 300 and so many days per year, and we get on this field at least 3 values per day. That means each plant is phenotyped at noon, during the night, during the day. We can extract a whole bunch of data that were absolutely not accessible for us. And we get data over time. That means we get growth curves, we get curves about plant development. This is something that was not accessible to us. So, briefly said, the FieldScan really has put our phenotyping at speed, and now we can optimally use the genotypic data together with the phenotypic data that we are gaining here in the field.
Okay, nice, good to hear. So for what kind of research are you using this tool for?
Well, in this FieldScan field, we are watching our vegetable crops growing. We did trials now on amaranth, and this also here, we are planting just an amaranth trial, and we had several trials with pepper and with okra. We were checking how the plants behave under heat stress, under flooding stress, and under conditions like now, conditions that vegetables really like for growing. We compare the growth curves, we compare all these parameters. In addition to the FieldScan data, we are taking for pepper, for example, data on pollen viability. For okra, we are taking data on yield. And like that, we can really do phenotyping studies and compare large populations for their behavior under different conditions. Generally, we plant here 300 accessions, 3 replications, between 4 and 10 plants per replication. It depends on the size of the plant, and the data collection is automatic. And in this trial here, we are just planting. We are checking the speed of early growth of around 400 different Amaranthus tricolor accessions in collaboration with Chircas, Japan.
Okay, interesting. Thanks for explaining us. So, Roland, what would be your suggestion to people who are interested to buy or invest in this kind of tool, into digital phenotyping equipment? What suggestions would you give these people?
Of course, for deciding which phenotyping system to buy, it is crucial to think of the research questions. The research questions should be able to be answered by the data the phenotyping system is delivering. Usually we think phenotyping systems deliver a lot of data and we can extract what we want. I'm not sure whether this is really true. When we decided for the Phenospecs system, we looked very much into the data that are produced by the system, and we needed to be convinced that these data are exactly those that we need in our breeding programs in our gene bank. Another consideration is the ease of handling and the cost of operating the system. With the Phenospecs system, I find that it is as simple as possible and as sophisticated as necessary. So the gantry and the movement of the gantry, this is something that is extremely stable. I would call this a very old and very proven technology, whereas the sensors are cutting edge technology, but also very, very stable. And this system needs a minimum of human intervention, and the running costs are extremely low, especially compared with controlled condition and conveyor belt based systems. There's absolutely no comparison. So the projects that we are having here at the center can cover the costs, and the data that are coming out are supporting these projects. And I think this is very important to consider when somebody is buying the system. About the size. Our field in the moment is 20 by 100 meters. We thought that this size is agreeable because it can accommodate a core collection or a small gene bank collection. With the time I find out that double the size would be better. Not only because it could accommodate more plants, also because the maintenance of the field, the maintenance of the soil fertility of the field would be easier. Now our system is fully booked, and it's really difficult for me to maintain the soil fertility. If the field would be bigger, we could leave half of the field for green manure and for recovery, while we are phenotyping in the other half. But now, with 100 by 20 meters, we have to see how we cope with that.
Thanks, Roland. So now I would like to introduce you to Ewert Kissel. So Ewert Kissel is the head of our software group, and they are developing the heart of our product, which is the Hot Control, which is the tool which is translating complicated sensor data into meaningful and resilient information. So he's the father of Hot Control, if you want. So Evo, tell us, what is important for the development of Hot Control? What is important for you?
Yep. Our major focus is on usability on the customer side. So our users are biologists, scientists, and we want to provide them as quick as possible access to the data they really care for. Mm-hmm. So the plant information, like plant height, leaf area, Ndvi, so they can start doing their research what they want, and take them as far as possible from all the hassle and the tedious work of going to your plant or putting your plant under a sensor, measuring it, taking a picture, taking it back to your workstation, even maybe processing the image, storing all that data into one file or organizing it at least, and then doing your analysis. So all this hassle we want to take away, and we want to give them immediate access to that core valuable information.
Okay, so that means you take care really a lot of automation. Can you explain us a bit what the different steps are and what kind of value your software delivers?
No, so as a company, Phenospecs, we have a great sensor that can measure or capture in 3D a plant. And we have this hardware automation that brings the sensor to the plants to capture all that raw data. And the first step of Hot Control is really automating that data acquisition. Mm-hmm. So the moment our sensors make an image, we get it from there, we process it automatically until we have plant parameters like height, leaf area, Ndvi, and we put it in a database ready for the customer to request whenever they want. And we even enable the customer to add extra information, metadata, like treatment, genotype, to it, so they can immediately have all this data combined when they download it and start using it.
Okay, so we heard before from Max, he was explaining us that we have about 15 standard parameters in our software. However, I can imagine that there's many people out there which are not happy with these 15 because they have other parameters they would like to assess. So how do you make these guys happy?
Yeah, so we have this request very often, or more and more even. And we had a great thought together with the team, and we came up with this machine learning module that we now recently released with Hot Control. And what the machine learning model does is it will take a customer variable, like a disease score, for example, as an input, and will try to predict this based on the input parameters it will get from the Phenospecs sensors. Mm-hmm. And it does it then also in this automated way, and this variable that is constructed can then be reused later on in any experiment, or you can combine data from different experiments to really capture it. So for example, a disease score might fit in a workflow of a customer, and they really depend on this one variable. Then this machine learning module is the ideal tool for them to use. So as an example for our machine learning model, we performed an experiment based on biomass. Mm-hmm. So it's a measurement where you have to destroy the plant to get the biomass. And of course, if you want to measure it over time, there is only one shot you have. And therefore, such a machine learning model makes the ideal tool to predict based on input data, so, which is our plant eye features, like greenness average, height, leaf angle, leaf area. They are then put into the model and predict the biomass itself. And this can be done over multiple growing seasons, so we can compensate for the effect of time in our model and then be reused in another growing season to, for example, separate or compare different genotypes based on their fresh biomass prediction without having to destroy the plants eventually.
Okay, nice. So I hear a lot of automation in here, so that means also that the hot control is also kind of a black box, or is there also possibility to get access to the different levels of the data?
Yeah, this is something we foresee. Even if we start off from the hardware itself, it already comes with a very nice API layer. So the hardware team really worked very hard on this nice API layer so that integrators can immediately tune the scanner, get and see the data. Then on a second level, we can offer all the 3D raw files for customers that are really proficient with working with these 3D files.
Okay.
They can just start off from there, and we provide the automation and getting all the data in one location. That's then our job. Or it can go to the software itself, where you can download the real plant data. So we really try to cover all these layers as much as possible. Okay,
nice. So what we observe that there is more and more phenotyping platforms which are being used, own developments, other suppliers. So there's a lot of different machines and systems which are generating data. So what is your way, and how do you solve this, the way to standardize and make this data comparable and workable?
Yeah. So we acknowledge that there is really a need of this generalization of data standards. So for interoperability between devices, it's also a question our sales team very often gets, and then gives this as a feedback to us, is that people request some kind of compatibility to data standards. Now academia came up with very nice standards called MIAPI. And they even provided a BRAPI, so an API endpoint layer, to these MIAPI standards. And we're now in the process, together with INRA, Wageningen University, and Elixir, to set up a project to define which data standards we can provide, and through which API endpoints, BRAPI endpoints, we can supply this to the customer. So that's one thing, and of course it will benefit the customer, because if they design a workflow based on data standards, and they have more and more of these automated sensors feeding their data into this pipeline, they can, in one go, with one workflow, calculate whatever they want to do with data, as long as it is in a consistent format. From our end, of course, it's interesting because people will start developing based on standards. So if we can tell them we are compliant, of course, it's one step ahead of others to use our system easily into a workflow.
Ewout, thank you very much for showing and presenting us your software and your work. So in the next step now, we're gonna meet our friends from the United States. So we're gonna set up a teleconference. So let's go and join me. All right, so now it's time to meet our friends in the United States. Hi Paul, hi Ross. So Paul, what's your background?
So I have a MS in crop breeding from the University of Maryland, where I worked on genetic diversity analysis in soybean germplasm using genetic markers. But I also have experience in information technology and software security and just general project management.
Okay, great. So when did you join the team?
I joined approximately 5 years ago. I contacted Phenospecs. It didn't look like they had anyone in the US or North America, and asked them if they needed help. At that point, they were virtually no clients in North America.
Excellent. So how did you guys start to build up business there?
So my first attempt was, I thought I'd leverage my extensive experience in the fast food industry, and I developed a sign spinning campaign. Needless to say, that was a little less than successful.
All right, so afterwards you then changed your strategy. So how are things going today in the United States?
So yeah, we attended lots of conferences, arranged meetings with companies and universities all around the country and major research institutions, and gave talks and conducted webinars with prospective clients. And it's worked out fairly well, so that today we have over 25 clients in North America from throughout the major research locations from California, RTP, and the Midwest, but we also have some up and coming ag tech areas, and this includes both academic and industry in a wide variety of sectors. So we're very happy with the progress we've made.
Cool. So Paul, can you tell us what are your responsibilities?
So I conduct market research and lead generation. I do conference analysis and management and just general marketing activities overall.
Okay. And where are you located?
I'm in Charleston, South Carolina, which is 4 hours south of RTP on the Atlantic coast, and I want to put in a pitch for the NAPPN meeting, the in-person meeting next year in Charleston.
Excellent. All right, thank you very much, Paul. So now I would like to introduce you to Ross. Ross is our sales representative in the United States. And if you have any questions about our products, this is the man to talk to. Hi, Ross.
Hi, Greg.
So Ross, tell us, when did you start at Phenospecs?
I actually started a year ago. I joined just before the last Phenome conference.
Okay. So tell us, how did you start then working at Phenospecs?
When I joined, I was offered a great opportunity to have 3 months of intensive training at our European headquarters in Berlin, Netherlands. And it was a great experience. Unfortunately, with the coronavirus, I didn't get to tour much of Europe, but there's a lovely part of Europe that I did get to experience, and I got to have a very in-depth training.
Excellent. So after your basic training and learning about our products, could you then start immediately with your commercial activities in the US?
Unfortunately, no. We actually had a very high-profile customer project with the University of Illinois with their Wright facility. Okay. And so it was a very large, high-throughput phenotyping device that needed to be installed. And so I was given the training to become the project manager for that installation. And it was very difficult, but with help from the university and others at the project site, we were able to get the installation done on time and on schedule.
Excellent. Good job. So explain us, so when a client is interested in our products, how does that go? How do you work with them?
I like to work very collaboratively, and I want to understand really how they do their research, what plant parameters they're interested in, and what type of research they're interested in, because that helps us find a product and how our sensors are going to fit into their research.
Okay. So in case a client is really interested to know more about our products, do you have options or possibilities also to give a demo or give him a taste of our products?
Yes, I actually have a portable unit of our plant eye scanner sensor, and with that we can utilize the plants that they have that they are doing their trials on, and I can examine the plants in their environment, walk them through the plant parameter results and all the measurements that we have taken. And then I can actually, when I leave, I give the customer the data that I have collected so that they can continue to analyze the measurements that we took.
Cool. So Ross, you proved that you are a very, very handy person as well. So in case that a client in the United States has a technical problem with our products, are you then able also to help him out?
Yes, I actually, with part of my training with the company in Europe was to work hand in hand with our support team. And so they can work remotely with most customers' problems and solve them extremely quickly. In the event of a larger problem or a product installation, I am able to quickly travel and go to their facility and help them with any kind of issues that they have.
Cool. So then let us know, where are you based?
I am based in Sioux Falls, South Dakota. Unfortunately, we have lots of winter weather here, so it's not as nice as Paul's weather, but my location allows me to travel equally very easily to either the west or the east coast.
Okay. Thank you, Ross. Thank you, Paul, for that. Have a great day and talk to you soon. So now I'm really curious to see what Max is doing. So let's go and check what he found out with his experiment.
Hey Greg.
How's it going?
Yeah, we're doing good. We gathered some data, and actually this data shows really good how powerful this system is. So right here we have the time series for the Hight. And this is the part where I started the treatment, so a salt treatment in this case. And we have a couple of groups. So the first group is the control. We can see it stays really nice and steady here. And then we have two treatment groups, so a heavy salt treatment and a light salt treatment. And the good thing is here, we can already catch after 10 minutes of time the change in height of these treatment groups. And after 20 minutes of time, we can see a really change from the control group.
Okay, nice. So we can really capture this salt treatment, which is, I guess, affecting the tugor. And the leaves might bend down, and this tiny changes can really be captured quite well. So this is height information. What does, for instance, like a functional trait tell us? Could you show us this data as well?
Yeah, so we could have a look at the Ndvi, which is quite interesting because it reflects the healthiness of a plant. And the system here has grouped the unhealthy parts of the plant and expresses that as a proportion against all plant material. So over time, again, we can see the control group stays nice and steady, whereas the treatment groups really show some dynamics. Here, the light salt treatment shows like an increase in unhealthy plant material, but not such a strong increase as the heavy salt treatment. So you can really see the change in the dynamics here.
Okay. Thank you very much. So do you have also like a quick snap to show us actually a report of the entire experiment?
Yeah, so we have a large variety of analysis tools. So for instance here, staying with the Ndvi, we can see the change in Ndvi per treatment in a box plot. So here we can see for the salt treatment, the change is most drastic, opposed to the light salt treatment and especially the control.
Okay. Thanks a lot for explaining us and showing us the device. So now we are at the end of our little show. I hope that you enjoyed it. I hope that we could provide you a little view behind the scene and that you get a better understanding what we do here at Phenospecs and what is driving us. I wish you all the best, take care, and see you very, very soon. Bye-bye.